Hey all, so we're going to keep solving with related rates here. Now we're going to be talking about distance as a type of problem, especially with triangles. So this is a very common type of related rates problem. Here you have 4 problems, and these are all going to be word problems here. Now with all of these, the first thing I'm going to recommend is start by drawing a triangle, because that is what they're going to rely on. So in number 1, it says a 5-foot tall actress on the stage is walking away from the spotlight. If the spotlight is 15 feet high and she is walking at 4 feet per second, how fast is the top of her shadow moving when she's 20 feet away from the light? So what this tells us here is we know it's a related rate problem because we see a rate. So I would say that the actress's rate, so I'm going to just say A stands for actress, is 4 feet per second. And that's how we tell it's a related rates problem. Other than that, we don't have any of our equations, so we're just going to go and say, let's go to our triangle. Now, this is a very similar problem that you've seen probably in geometry and even in some of your lower level classes, is that we have a person standing in front of a light, casting a shadow, like so, and that is 15 feet up. She is 5 feet tall. And in this case, though, the main thing that's different from previous questions that we've seen like this is that this person is in motion. So her motion, as we said, is 4 feet per second. Now, I'm going to call this distance A right here, and we want to know how far along this end of the shadow is, so let's call this X. So there to A, then all the way here is X. That's what we want. We want to know how fast is the shadow moving. And if I drew in the shadow, right, that would be here as she's walking away. Now, if you remember from previous lessons, these are similar triangles. So the relation of A and X, so that we can create an equation, we have 15, and then this length all the way there is X. This is similar to the shorter one, which would be 5 feet for the actress, and then her shadow, which is X minus A. They are similar, which means that we can set up a fraction with them. So we would say, in this case, 15 over 5 is the same as X over X minus A. I would relate that even closer to say that we have then 3 is equal to X over X minus A. And now we have our equation that we can deal with. Because looking at this problem, she's 20 feet from the light, so that means that A is equal to 20. We could find X if we wanted to. We could find, and we're looking for dx dt. This is what we want. And now we'll start with our equation. 3 is equal to X over X minus A. Now I could do d dt at this point, but I don't really like the quotient rule. So I am going to multiply each side by the denominator. So I get 3x minus 3a is equal to x. I would then subtract the x and add the 3a. So I get 2x is equal to 3a. You could do more from here. I'm going to just take this as d dt, since it's a related rates problem, of both sides. The derivative of 2x is 2, then dx dt. The derivative of 3a is 3, and then dA dt. Now we know dA dt, as it's given, is 4 feet per second. So 2 times dx dt is equal to 3 times 4. Divide both sides by 2. The rate of the shadow on the ground is 12 divided by 2, which is 6. And then the word problem gives us our unit, which is feet per second. So again, looks like a very complicated problem. Doesn't even maybe seem like a calculus derivative problem. but it's all about recognizing that it's a related rates problem and writing the equation. Now, a very common equation involving triangles and distance is going to come up here, and we're going to see lots of Pythagorean theorem problems as well. So, two boats 10 kilometers apart start sailing north at the same time in parallel. If one of the boats is traveling 45 kilometers per hour, oh, there's our sign that we have rates, and the other is going 55 kilometers per hour, how fast is the distance between them changing after 2 hours? So again, we know it's a related rates question because we see a rate. Now I'm going to draw the picture. So we start with two boats. I'm going to call them A and B. And we know that they are 10 kilometers apart. And they both start sailing north. Now A is a little bit slower. This would be dA dt. The speed of A is 45. And B is a little bit faster. dB dt is 55. So the question becomes, this distance between them here, I'm going to, because I want you to think about the formula, dc dt. Because we have, here is our triangle, right like so. Our Pythagorean theorem, old friend. So that's the equation we're going to use to relate that equation. I'm going to zoom in a little bit on it just to make the math a little bit easier. The base is always 10 kilometers since that's the distance. This C is our unknown. Now this distance between them is B minus A. It's the difference between those two. Now that speed then, this distance, the derivative of it is 10 because that is the difference between 55 minus 45. That its length after 2 hours, this will just take a little bit of recalling. Remember that distance is equal to speed times time. So if the speed that vertical distance here is growing is 10 kilometers per hour, for 2 hours, its length is 20. But it's changing, so we won't write that quite yet. What we do know is that by the Pythagorean theorem, a squared plus b squared equals c squared. The base is constant, so I would write a squared plus 100 is equal to c squared. And remember, we know that dA dt is equal to 10. We know that A is equal to 20. And we want dC dt. This is what we want. So I'm going to start by using our d dt. The derivative of a squared is 2a, and then dA dt. The derivative of 100 is 0, it's a constant. The derivative of c squared is 2c dc dt. And we can then plug in what we do know. We know this is 2 times 20 times 10 is equal to 2c times dc dt. We still have an unknown variable. That's all right. We can use the Pythagorean theorem to find out what c is equal to right here. Using our triangle that we had, we have 10, 20, and c. So therefore, 100 plus 400 is equal to c squared, meaning that 500 is equal to c squared, meaning c is equal to 10 root 5. So after plugging that in, we would then get a simplified 400 on the left side is equal to 2 times 10 root 5, 20 root 5, dc dt. When we divide, I divided by 20, nice and easy. Then we get 20 over root 5. And finish that up, rationalize the denominator. Root 5 times root 5 which is equal to 20 root 5 over 5, or 4 root 5. That is dc dt, and we get that our unit from here is kilometers per hour. So a lot of these are going to be similar, and they're going to be Pythagorean theorem problems. If you have any questions, please let me know. And